It's time to talk about the most underrated and even misunderstood feature of geomorphology. It is responsible for shaping major terrains, and I bet you've never even heard of it. It's the principle of laminar flow. It is defined as a type of fluid motion where the fluid moves in smooth, parallel layers without any disruption or mixing between the columns. These columns have increased water velocity. This type of flow can be observed in rivers and is responsible for parallel channels and drumlins. But where it gets misunderstood is when it is considered synonymous with low current speed and non-turbulent flow. In high-speed current conditions, the laminar flow itself becomes a turbulence, either random or in the form of vortex columns. Now let's take this understanding to geomorphology. The laminar flow columns will erode parallel channels in close proximity to one another. Way too close and way too large for rainfall to be responsible. Now, what you will find highly correlated with this landscape are paths of scours. These depressions were carved from an undulating force that went through these channels, either during or after the laminar flow erosion. The sinusoidal movement is why these lakes tend to be evenly spaced. This is a motion excess energy is diverted into. Ice sheets are made of interconnected solid objects, which respond to rigid body dynamics and not fluid dynamics at all, so they cannot be responsible for drumlins. They would simply bulldoze them into moraines. This is why scientists have introduced the subglacial flow model. But it doesn't explain the drumlins in equatorial deserts. Neither can glaciers make large ripple formations, which are paired with drumlins nearly everywhere drumlins are found. The desert drumlins are called longitudinal dunes made by wind. Well, wind isn't observed to make this, it moves rather disorganized over land. It's the scours in Africa that should really put the wind theory to rest, as wind isn't heavy enough to produce scours, only to fill them in. Only sheet water flow remains as something physically possible to make these erosional patterns. But crucial is a high current speed in order to flow in a straight path over such long distances, and energetic enough to make scours. Once you see the paths of these currents, you can't unsee them, so send this to a friend.